Hi, let's talk free fall this time. So, what exactly is it that causes an object to fall? Whether you drop it, or whether you throw it up, or whether it's falling off of something, or whether you even throw it at an angle. So, if I have this tennis ball here, and I take the tennis ball and I drop it, why does it fall? If I take the same tennis ball and toss it up, and it comes back down again. Why does that happen? If I put the tennis ball on something, and let's suppose that it, whoops, rolls off, or even if I take this tennis ball and I toss it over there to my son, all of those things happen because of free fall. And free fall is based on something called gravity. Now, there are two terms that are related to gravity. One is an acceleration due to gravity, and the other one is a force of gravity. Okay? Now, gravity is something that happens because of that dent that's created in space. And I believe, if you remember right, we talked about different objects will have different size dents. Earth, because it has way more mass, has a bigger dent than something, say, the moon. Our moon on Earth would have a smaller dent. So if you looked at the number for the acceleration due to gravity on Earth, technically it is 9.8 meters per second squared. On the moon, it's more like 2.2 or 2.3 or something like that. Now, there's also something called the force of gravity. Now, force of gravity and acceleration due to gravity are two different things. The force of gravity is going to be measured in something called a Newton, or a capital N. So forces are measured in newtons. Accelerations are measured in meters per second squared. So they're not the same units, so they must not be the same things, okay? So there's an acceleration due to gravity and a force of gravity, two completely separate things. Well, actually, they're related to each other. One causes the other, okay? All right, now, when we talk about acceleration, we need to review a couple of different things. So, what type of acceleration is needed to speed an object up? Well, if you're going to speed an object up, your acceleration has to be in the same direction as the object is going, or the same direction as its current velocity. What type of acceleration then is needed to slow an object down? Well, the acceleration needs to be in the opposite direction of the current velocity. So if it was traveling with a velocity in one direction, in order to slow down, you'd have to have an acceleration in the opposite direction. What exactly does it mean if something has no acceleration? Another way to say that is the acceleration is zero. That means your velocity isn't changing at all. So you're going the exact same speed the whole entire time. Now, what circumstances must be met in order to consider an object to be in free fall? Well, that force of gravity is the only unbalanced force on the object. So all the other forces are either equalized or there aren't any other ones, okay? Now, what happens if I take that object and I throw it up and it comes back down? What happens right here at the very, very, very top? What is its velocity for a split second at the very top? Its velocity at the very top is zero, okay? And notice that it says the y velocity in this final question. What is the y velocity at the peak? Now, why is that y velocity important? Well, when you toss an object at an angle like this, like I threw that tennis ball to my son, you're going to have a velocity in the x direction. And at the same time, you're going to have a velocity in the y direction. And we're going to talk eventually here about the fact that those things are separate from each other, so we can look at them separately, okay? So free fall has everything to do with gravity. It's the only unbalanced force, gravity.